In this video, I'm going to look at introducing you to composite functions. So we'll have a wee look at an example of revision from last year, just to get you started off. So the example then is a function f is defined by f of x equals the cubed root of x plus 5. Evaluate f of negative 27. So we've got the function that we're starting off with, so that's f of x is equal to the cubed root of x plus 5. Now I'm going to take you back a bit to primary school, when you first started looking at functions, but you may or may not have been aware that that's what you were doing at the time, and you looked at function machines, and here you have an input, then you have the function, which in this case is the cubed root of x plus 5, and then you had an output. So you might remember that from before, and in this case our input is x equals negative 27. So basically everywhere there's an x in this function, we are going to be substituting it, replacing it with negative 27. So we can substitute that in there. F of negative 27 is equal to the cubed root of negative 27, add 5. So if we start evaluating that, we then know that f of negative 27 is equal to negative 3 plus 5. And we know then that that is 2. So you can see that the input in this function machine was x equals negative 27, and the function did its thing, and the output was 2. So f of negative 27 is equal to 2. Now, if you're not too sure about that from last year, by all means take it down as an example in your jotter, and if not, if you're quite happy with that, that's fine. Now, let's move on a wee bit to composite functions. So what we just had was this. Okay, so we had that function in there, the input was x equals negative 27, and we got our output out, which was 2. If I want to add another function into the mix here, I'm going to tell you that this function is g of x equal to x minus 6. Now you can see that I've already got my input to this function. My input is 2. So if I put 2 in here, g of 2 is equal to 2 minus 6, which we know is negative 4. So my output is g of 2 is equal to negative 4. Now, if I just have a wee look here, g of 2, so 2 was the input, but actually that input was 2 is actually equal to f of negative 27. So surely then that means that my output of negative 4 is actually equal to g of f of negative 27. Let's have a look at another one. So I'm giving you the two functions to start with here. So you can see that we've got p of u is equal to 4 minus 5u, that's our first function. And then our second function is q of u is equal to u squared plus 2. And the input is u equals 2. And I want to know what is the output over here. So what is p of q of 2? So let's put u equals 2 in here, and that tells us that p of 2 is equal to 4 minus 5 multiplied by 2. That's 4 minus 10, which is negative 6. So we just work through that substitution. So we know that our output from that first function is p of 2 equals negative 6. Now that output from the first function so happens to be the input for the second function. So q of negative 6 is equal to negative 6 all squared plus 2. which gives us 38. So the output Q of -6 is equal to 38. But actually, that -6 was P of 2. So our output is actually Q of P of 2 equal to 38. And what we can actually say then, given what we've done here with these function machines, is that a composite function is when one function is inside another function. So if we look here, function f actually ended up inside of function g. So the output of function f was the input of function g. And likewise here, the output of function p was the input of function q. So you could say that the function p ended up inside function q. So there's an introductory exercise in your booklets, so if you go and try that just now.